Good morning, Year 10 mathematicians. Just going to continue with Unit 5, Shape and Space. Another geometrical transformation you need to know about. It's called an enlargement. The main objective today is to perform an enlargement with a positive scale factor. Now, the definition of an enlargement is pretty intuitive, so it changes the size of the object, but not the shape. In other words, the shape is in the same scale. Now, one illustration for this would be maybe you've got an object on a table. So it could be some vase or something. And then behind that object there is a wall. And if you took a torch and you positioned that torch in front of the object, it would create a shadow on the wall. Now, the torch itself, depending on where you position the torch, the shadow would change size, position, etc. But the object, the shadow itself, would be an enlargement of that vase. So we are going to consider the maths equivalent of this, where you've got a shape to enlarge, and we have the maths equivalent of a torch, called a centre of enlargement. So the instructions for an enlargement are the centre of enlargement, so that's effectively where the torch would be, and also the scale factor, which is how big the object is going to become. Now, let's have a look to see what a question would look like. So we have e.g. number 1. Find the centre of enlargement and scale factor for the enlargement below. So we've got a shape A that's been transformed to shape B. And we have to find two things. So the scale factor and the centre of enlargement. Now the scale factor is the easy thing to find. That is how much bigger the new object is compared to the old one. So if you took just one length, which is easy to find, so that length would be the bottom there, which is 4 across, and then you worked out the corresponding length on the other shape, so that is 12 across. The scale factor is equal to 12 divided by 4, which is 3. So the object B is 3 times bigger than object A. Now, to find the centre of enlargement, again, you have to annotate the diagram. So this is effectively, imagine this is the object as a shadow on a wall. This is the object sitting on the table. And you're going to try and find where you position the torch in order to create this perfect shadow behind it. So in order to do this, you add 2 or 3 lines in, and they're straight lines which join corresponding corners. That's the key thing. Corresponding corners, not 2 random corners, so like that, but they have to be matching corners. So the bottom left of this one matches with the bottom left of this one, and I draw a straight line going through those points, like so. Then pick another pair of corresponding coordinates. So I'm going to pick the top ones. you only need 2, but we could do 3 of them. So pick these 3, this pair as well. If you do this perfectly, they should all go through exactly the same point, which is there for me, which is, if I drew this perfectly, 5, -2. 5, -2. So all of the corresponding corners end up going to one unique point, and that unique point is effectively where the torch, if you like, is positioned, and that, in maths terms, is called the centre of enlargement. So centre of enlargement is equal to 5, -2. Now, another way they could ask you to do these questions is actually perform the enlargement itself. So EG number 2 is going to enlarge shape A, so that original shape, by a scale factor 2, so it's going to be twice as big, with the centre 2, 1. Now, yeah, if I just said scale factor 2 without a centre, you wouldn't know where to position the shape, even though you know it's going to be twice as big. So it's really important that you label the centre, because that tells you where the shape is going to end up. So the centre, just like we do with rotations and reflections, we label mirror lines and centres of rotation. We label the centre of enlargement, which is that point there. Okay, and to perform the enlargement, the scale factor means things have got to get twice as far away from that centre. So each corresponding corner is going to get twice as far away from the centre as it originally is. So this point on the left is 2 left, 1 down away. That needs to double. So rather than 2 left, 1 down, it needs to be 4 left. Starting from the centre, 4 left and 2 down. So that ends up there. This point going to the top corner is 1 right, 2 up. That needs to double because the scale factor is 2. So that would be 2 right and 4 up. And finally, this bottom point there is 2 right, 1 down. That needs to be 4 right and 2 down. So that goes there. And when you join the dots to get the actual shape itself, you should get something like this, and that shape is called C. And if you do a quick check, remember that original shape had bottom length of 4, this new shape has a bottom length of 8, so that does make sense. One of the additional checks you can do is if you drew in the annotations that I did above, the green lines, so to visualize those going through corresponding corners, then they all pass through the centre of enlargement, which means the position is correct as well. So that's pretty much it. Now the questions I'd like you to do are on, just write it there, they're on page 345, exercise 3, and I would like you to do question 1 and question 2, and then if you turn to exercise 3 star, I'd like you to do 4 and 5. Now there's not many exam tips I can give you for this one apart from potentially annotating the diagram. So always label in the center and always label in in these straight lines to check if everything goes through the center of enlargement. Okay, so maybe a quick exam tip squeezed in there. Draw straight lines through the corners to check center of enlargement is correct. That's it.